Problem 4. Find the volume of the solid obtained by rotating the region in the first quadrant bounded by y equals x to the power 6, y equals 1 and y-axis. Okay, above around the y-axis. All right, so let's understand this picture. You want y equals x to the 6, that's this curve. You want the line y equals 1, that's the horizontal line y equals 1. And then you want the y-axis, that's the y-axis. So the region between this line, this curve and the y-axis. So that's this particular region, and you want to rotate it around the y-axis. Okay. All right, that was. So you want to take this region, rotate it about the y-axis. When I rotate this region about the y-axis, this is what we get. It is a solid bowl looking. It's solid, full of it, right? So because we rotated it about the y-axis, all our slices, cross sections, we are going to look at are horizontal cross sections, which gets us the fact that the solid is supported on the y-axis over the interval 0 to 1, because that was y equals 1 was the upper bound. When y is 1, because y is x to the power 6, x is also 1. So that point is 1, 1. And that's your upper limit, right? So y equals 0 until y equals 1. Each thin cylinder here, each slice has thickness delta y. All right. For each y here from 0 to 1, the cross section is a circle with radius. So what's the radius of this cross section? You're going to start from the center, go across to the right. Because you go across to the right, you're looking at the x coordinate of this point. X coordinate of this point is 6th root of y. In other words, each cross-sectional circle has area pi radius squared. Remind you, radius is the x coordinate. X coordinate itself is 6th root of y. So now when I square it, it is y to the power 2 over 6 or power 1/3. So that's your cross-sectional area. Therefore, volume of the solid is limit 0 to 1, 0 to 1, cross-sectional area dy in terms of y, right? When I take its antiderivative, I get y to the 4/3 over 4/3. Limit 0 to 1, and don't forget the pi, constant pi. Substituting, we simply have y equals 1, y equals 0 gives you nothing. So 3/4 pi. 3 pi over 4. Next problem. Find the volume of the solid obtained by rotating the region bounded by the curves x equals y squared and x equals 1 about the line x equals 1. Notice x is y squared, x is 1 about the line x equals 1. So let's look at that. X y squared looks like that. X equals 1 is the vertical line. All right. And you want to rotate it about the line x equals 1. Region bounded by the curves x equals y squared, x equals 1. X equals y squared is a horizontal parabola, if you want to call it that. And the vertical line is x equals 1. You want to rotate it about the line x equals 1. When you rotate that picture about x equals 1, you get a picture like this. right? So notice, because we rotated about a vertical line, all our cross sections are going to be horizontal, right? All our slices are going to be horizontal. So this solid is supported on the y-axis from -1 to +1 on the y-axis. All right. Furthermore, for each, so because we are looking at horizontal cross sections, for each y value between -1 and 1, the cross-sectional circle has to have the following radius. You're starting from here. So what is it? You go all the way to here. So you want this distance. All right. We don't know this distance, but we know here is y-axis. You know this distance, that small horizontal distance is x-coordinate, x which is y squared. So that small distance is x-coordinate, and this entire distance is 1 because that's where the line is placed. So from 1, you take away x-coordinate and you get radius of your circle. So from 1, you take away the x-coordinate. Remember, on this curve, x-coordinate is the distance from the y-axis. So 1 minus x is the radius of a horizontal circle. But x itself is y squared. So 1 minus y squared. So each cross-sectional area is pi times radius square. 1 minus y squared power 2. So volume of the solid is integral -1 to 1. Remember, -1 to 1. Cross-sectional area in terms of y. So you want to take derivative with respect to y. Power 2, 1 minus 2y squared plus y to the power 4. Don't forget, pi is a constant, so I can just pull it out. When I take antiderivative, I get y minus 2y cubed over 3 plus y to the 5th over 5. The limits of integral being 1 and -1. So, if you notice, this is quite symmetric. The top is quite symmetric to the bottom. So I can simply take twice 0 to 1 if you like, or you actually substitute and you check, you get the answer 16 pi over 15 cube units. So 16 pi over 15 cube units. All right. Next problem, let's go over it in our next video. Until then, bye.